Hi everyone, I am G.DHARANI, Assistant Professor of Biochemistry, A.D.M. College, Autonomous, Nagapattinam. Today, we will discuss the topic is Bioenergetics, Introduction of Bioenergetics. Energy is required by all animals to sustain life. Source: food, natural productivity, body source. Then, lecture objectives. How much energy is needed by aquatic organism? How does it vary from terrestrial? What are the source? How is energy partitioned for various users? Okay, this is the lecture objectives. How much energy is needed by aquatic organism? Then second question is how it varies from terrestrial. Then third question, what are the sources of bioenergetics? Then final question, how is energy partitioned for various users? Okay, this is the introduction of bioenergetics. Lavoisier first demonstrated that oxidation from nutrition was some form of combustion (burning). Okay, this is introduced. Rubner in 1894 was his first demonstration that fundamental law of thermodynamics also applied to interact living animal system. Third point, organic matter is converted to process. This process is converted to CO2 plus H2O plus energy. This energy is released. Understanding energy transform is only possible when it is converted from one form to another. Energetics. Energetics is the study of energy requirements and the flow of energy within system. Bioenergetics. Bioenergetics is the study of the balance between energy intake in the form of food and energy utilization by animals for life sustaining process. What is the process? Process: tissue synthesis, osmorylation, digestion, respiration, reproduction, locomotion, etc. Okay. The original energy source for food energy is the sun. Energy from the sun is converted by the photosynthesis into the production of glucose. Okay, glucose is the hydrocarbon source from which plants synthesize other organic compounds such as COH, protein, lipid. As previously mentioned, one must consider the quality of this source. This is continue of introduction of biosynthesis. Animals are not heat engines. They can't use the multitude of source of energy we have, for example, flywheels, filling objects, the tide, etc. Must obtain their energy from chemical bonds of complex molecules. How do they do it? It is a nutshell. They oxidize this bond to lower energy states using oxygen from the air. Tricks: some bonds have more energy than others. This is also continue the introduction of biosynthesis. Most aquaculture animals obtain their energy from feeds. As mentioned, some bonds have more energy associated with them others. When you have many nutrients comparing a feed, the energy level of that feed can vary substantially. Availability of energy varies according to feed, ingredient and species. Growth is the end point of net energy. This is the glycogen molecule structure. This is converted to new non-reducing terminus is finally converted to elongated glycogen with N+1 residues. This is also lipid molecule. Lipid molecule also contain glycerol. 3 fatty acid is finally converted to triglycerol. This is also introduction of biosynthesis. Energy goes through many cycles and transformation always with loss of heat. Can be released at various rates. Can exploding with comfort piles. Nutritional energetics. Nutritional energetics involves the study of the source and transformation of energy into new products. of all dry matter we consume, 70 to 90% goes of synthesis of new products. Energy form. This is the main important point. Matter and energy are basically the same. It is often convenient to consider energy a property of matter. Bracket. This is SI unit is K called by gram feed. Nutritive value of food item is often by calories. What you are used to seeing in the source is not calories but kilocalories or calories. Common form of energy in the cell is ATP, adenosine triphosphate. Okay. All processes in the animal body involved changes in the body. The word energy was first introduced in 1807 and defined as ability to work. Found in many forms: heat, kinetic, electromagnetic, resonance, nuclear and chemical. For other processes, chemical energy is the most important. For example, ATP, heat energy. First of all, we see the heat energy. The measurement of energy required converting it from one form to another. What we typically measure to heat? Why? According to the first law of thermodynamics, all form of energy can convert to qualitatively into heat energy. Heat energy is represented by the various constituents of the diet. This is also heat energy. However, the body is not a heat engine. Heat is an end product of reaction. It is only useful to animals to keep the body warm. Chemical reaction either generate heat called as delta H or require heat called as minus delta H. Okay, this is the unit of heat energy. The basic unit of energy is the calorie called. It is the amount of heat required to resident the temperature of 1 gram of water 1 degree Celsius. For example, measured from 14.5 to 15.5 degree Celsius. It is such a small unit that most nutrients prefer to use the call bracket 100 calories REM. This is the call in more common supermarket calories. Okay, this is the other unit of heat energy, BDU. BDU means British Thermal Unit. Amount is amount of heat required for residence 1 lb of water 1 degree Fahrenheit. International unit, the joule, minus 1.0 joule to 0.239 calories or 1 calorie equal to 4.184 joule. A joule is called as J. A joule is the energy required to the accurate a mass of 1 kilogram at the speed of 1 meter per second as distance of 1 meter. This is the energy flow of often show a diagram. Every text as shown into ideal suitable diagram. This is distillable energy is converted to the metabolic energy is called as ME. Metabolism energy is converted to related energy called as RE. This is also converted two types. One is total energy, one is metabolic energy. So finally, the total heat production is called as HE. He produced basal metabolism, digestion and absorption, thermal regulation, waste formation and excretion. This is also continued the energy term. It contains four important types: gross energy, intake energy, fecal energy, digestible energy. Gross energy is called as GE, intake energy is called as IE, fecal energy is called as FE, digestible energy is called as DE. First of all, we see the gross energy. Gross energy is the energy released as heat resulting from combustion called by gram. Intake energy called as IE. Gross energy consists of food bracket lipid protein. Fecal energy called FE. Gross energy of fecal digestive expiratory product. Digestible energy called IE minus FE. IE minus means intake energy to minus fecal energy. This is also continue the energy system. Metabolized energy called ME. Metabolized energy is the food microbes that lost of feces, urine and through gill excretion. For example, ME. ME means metabolic energy equal to IE minus FE plus UE plus ZE. This is the energy term formula. Second of all, we see the urinary energy. This urinary energy called UE. Total gross energy of urinary product of unused increased compound of metabolic product. Third, we will see the energy grill excretion energy ZE. Gross energy of product excreted though grill high in the fish. Surface energy, we call the SE, surface energy. Energy lost to swelling of mucus, scales, exoskeleton. This is the also continue the energy system. Total heat production HE. Energy lost in the form of heat. Heat lost is stored from metabolism. Thus, HE is an estimate of metabolic rate. Measured by temperature change or oxygen consumption rate. Divided into number of constituents as per energy follow diagram. Okay. Total heat production. This is also present in the bioenergetic process. It contains basal metabolic rate, heat of activity, heat of thermal regulation, heat of waste formation, specific dynamic action. First of all, we see the basic metabolic rate. Heat energy released from cellular activity, respiration, blood circulation, etc. Heat of activity. This is the heat produced by muscular activity. For example, maintain position in water. Heat thermal regulation. Heat produced to maintain body temperature. Heat of waste formation. Heat associated with production of waste product. Finally, specific dynamic action. Increase the heat production following assumption of feed various with energy content of food, especially protein. This is the focus. First of all, we see the gross energy. Energy content of a suitable, for example, food, is the typically determined by completely oxidizing the compound to carbon dioxide, water and other gas. The amount of energy given of this measured as known as gross energy. Gross energy, also called as GA, is measured by a device known as bomb calorimeter. This is the gross energy of fetus. Glucose contains 3.7 kcal per gram. Triglyceride contains brief fat 9.44. Soybean oil contains 9.28. Caseins contain 5.84. This is the gross energy of feedstuff. Fat contain triglycerides. Fat have about twice the E as carbohydrate. This is because of the relative amount of oxygen, hydrogen and carbon in the compound. Energy is derived from the heat of composition of these elements. C equal to calories equal to 8 kcal by gram, heat equal to 34.5 etc. Typical heat from consumption of fat is 9.45 kcal by gram, protein is 5.45, COH carbon dioxide is 3.75. Available energy. Gross energy only represents the energy present in the dry matter, DM. It is not a measurement, it gives energy value to consumed animal. In difference between gross energy and energy available in the animal varies greatly from different food sources. The key factor to know in digestible the food item is digestible energy also varies by species. Digestible energy, second energy. The amount of energy available in an animal from feedstuff is also known digestible energy, DE. REM. DE is defined as the difference between the gross energy of the feed item consumed and the energy lost in the feces. Two methods of determine direct or indirect. By the direct method or feed, intent consumed and feces exceed or measured. Digestible energy. The indirect method involved only collecting the sample, feed and feces. Digestion coefficient are calculated on the basis of radiation of energy to indicated in the feed and feces. Indicator. What is indicator? Indicated an innate indigestible compound added to the feed. Indicator also. Natural. For example, fiber and ash or synthetic. This is the DE calculation, direct method. Okay. Percentage of direct method equal to feed energy minus fecal energy divided by feed energy into 100. Indirect energy method formula. The percentage of DE, direct method, equal to 100 minus overall feed energy divided by fecal energy into fecal indicator divided by feed energy into overall into 100. Okay. Metabolism energy. This is one of the energy terms. Even more dilated. Represent DE mucus energy lot of the body through gill and urinary wastes. Most difficult to determine why all urinary waste in water. How do you collect that? Example, percentage ME. ME means metabolized energy. Intake energy minus E lost in fecus. Example, urine divided by feed energy into 100. Okay. Use of MES-DE wounds allow for a such more absolute evaluation of the dietary energy metabolized by tissues. However, ME offers little advantage over DE because most energy is used for digestion in fish. Energy losses in fish, though urine and grill, does not vary much by fetus. Fecal energy loss in more importance, causing a fish to eat involuntary in not a good representation of actual energy process. This is the energy ration for rainbow thought. This is energy balance in fish. Energy flow in fish is similar to that in mammals and birds. Fish are most efficient energy use. Energy losses in urine and grill excretion are lower in fish because 85% of nitrogenous waste is excreted at ammonia. For example, urea in mammals and uric acid in birds. Heat increment as a result of ingesting feed in 3 to 5%. ME in fish with 30% in mammals. Maintenance energy requirements are lower because that does not regulate body temperature. These use loss energy to maintain position. This is the terrestrial with aquatics. This section concerns the requirement of energy by aquatic animal. How energy is present, what is used for, how is measured. A major difference in nutrition between fish and farm animals is the amount of energy required for protein synthesis. Protein synthesis is referred to building of protein by tissues replacement, cell structure, enzyme, hormone, etc. Fish have a lower dietary energy requirement. Factor affecting energy partition. Factor either affect basal metabolic rate, for example, body size, or affect the changes. Those affecting BMR are the following. Body size one is, second one is oxygen availability. First of all, we see the body size. Body size, non-linear, Y equal to A into B for most physiological various, B equal to various usually range between 0.7 and 0.8. Oxygen availability, have conformed and non-conformed process. This is the O2 conception of by size. X-axis and Y-axis. X-axis contain mass mg, then Y-axis contain oxygen. This is the factor affecting energy, temperature, osmoregulation, stress, cycling. First of all, we see the temperature. Temperature. Most aquaculture species are significant effect. Accumulation required aquaculture situation may repeat changes. Osmoregulation. Changes in salinity result in increased cost of energy. Stress. Increased BMR regulating from heightened level of waste, low oxygen, growing, handling, pollution, etc. Cycling. Various animal processes are cycling in nature. For example, reproduction. This is also a factor of energy. Those factors not affected BMR. Gonal growth, locomotion. Gonal growth is most energy derived from muscle growth into cogenous. Deposition of lipid can represent 30 to 40% of body weight. Locomotion. Major part of energy assumed varies due to body shape, behavior and size. Aquatic with terrestrial issue. Another index, gross conversion efficiency, called as K, refers to K, often used on indicator of the bioenergetic physiology of fish under various conditions. Those refer to the another bucket. Measurement growth rate relative to sea feed intake over similar time periods. Both factors are related to body size. K equal to SGR divided by RFI into 100. SGR means RFI means. This is energy and growth. Dietary excess of deficiency of useful energy can reduce growth rate. This is because energy must be used to maintain an voluntary activity before it is used from growth. Dietary protein will be used for energy when the diet is deficient in the energy relative to protein. When the diet contains excessive energy, feed intake is typically reduced. This also reduced intake the protein and other nutrients needed for growth. Dietary source of energy, protein. Considerable interaction between major nutrient group as energy source. Protein can be used as an energy source. Not typically used because to cost and used for synthesis. Example, growth. Optimal ratio of protein energy is around 22 mg, called as kJ. Species variation. 17 for triple R, digestive variation, temperature variation. Energy and growth. Consumption of diet with low protein to energy radius can lead to fat resumption acid. This is understandable in food fish because it reduces the stress out yield and soften nips. Low protein. Energy diet can be useful for maturation animal sedative released. Energy requirement of fish. Determination the energy requirement of fish has been difficult task. Snow is coming. Most research has been devoted to identifying the protein requirement, major minerals and vitamins. In the past, feed were formulated letting energy value is float. Excess or deficiency of nutrition energy does not often lead to poor health. This is also continue the energy requirement of fish. Further, if feed are formulated with practical feed snuff, their energy levels are not likely to be off. It is really under matter of cost. Protein is the most expensive component of the diet. In terrestrial, feed is consumed to meet energy requirement. Thus, as energy level of the feed goes up, protein level is also designed to go up. This is also continue the energy requirement of fish. This is because terrestrial animals are typically feed on A.D.MCOLLEGE basis. Fish, on the other hand, are not feed this way. They are feed on a feed allowance basis. Various studies have shown that the distributable energy requirement from channel, catfish and crab was around 8.3 to 9.7 kcal DE by 100 gram fish per day. In terms of weight, dietary level of DE and protein typically group of with age. This is the protein DE requirement of channel catfish by age. DE or protein requirement typically follow each other. So the DP is P ratio. This is partially due to the fact that fish grow faster when young. However, this influence of energy is stronger than that of protein relatively to growth. Energy level is diet usually range similar to those of fish. This is also energy requirements of aquatics. The objectives in formulating diets of most aquatic fishes in the same. Finding a cheap energy source that is distributable and will source protein. Glucose is not acceptable in that it causes high blood sugar level, poor growth, poor survival. Complex dietary fruit better. Typically, COH typically fat, protein for growth. Increase the dietary energy trends in increased performance when a diet low in protein is fed. Energy problem. Lipids of carbohydrate are typical energy source of concern. Unfortunately, concerns are unable to tolerate diet having greater than 10% lipid. This means that the major energy source may be delivered from COH. Various COH are used to various degree by consume, making it difficult to calculate the true energy value of diets. Okay, thank you.